Today we're going to talk about the ASOF join. This is what I like to think of as the timestamp join, because the ASOF join allows us to join records from two different tables and keep a latest record, generally according to a timestamp. This example is going to be in DuckDB, but I will mention that ASOF joins also exist in Snowflake. The syntax is slightly different though. So while these examples will be in DuckDB, I'll also show the corresponding syntax for Snowflake. Lots of traditional databases do not have the ASOF join. So if you're using something like SQL Server, Postgres, or SQLite, you will not have the ASOF join, as we'll see it today. The data that we're going to use for the examples is some users and some events. The users have a username and a date time that their account was last reviewed, and the events have an ID, the user they correspond to, when the event happened, and what the event corresponds to. To work up to the ASOF join, let's start with a simple left join. So let's say we start with the users. We want to join on the events so that we can see all the events corresponding to our users. We'll start with a simple select star from users. We'll do a left join onto the events. And the way that we associate these is on the users user ID being equal to the events user ID as well. And let's grab some columns for now. Let's forget about the username, but we will keep the last review date time, and we'll keep the events columns as well, apart from the event user ID, because we're already keeping the user ID from the users table. Here we go. Let's give this a run to see what we get. Of course, we could have done the join condition instead of using on. We could have used using user ID like we saw in the last video, but we're going to stick to on for the moment. Just to make sure that the output is in a nice order, let's also specify an order. Let's do order by the user ID and then the event ID. So I'm going to rerun this. Now we're going to see all of the events first ordered by the user and then by their events. For this example, let's say we want to see the events just before their account review. We're going to work up to seeing the latest event before their account review. But let's work up to seeing just the ones before the latest review. How would we do this? Well, we'd just simply add on an AND condition in here. We would only keep the records where the user's last review date time is greater than or equal to the event's event date time. Or if you like to think about it the other way around, where the event date time is less than or equal to the review date time. So now I've updated my code. Let me rerun it. And you'll see that for user 1, we haven't had any events before their last review date time. Users 2 and 3 have had a fair few. And finally, user 4 also hasn't had any. But we're getting quite a lot of events for users 2 and 3. I was saying that we're going to want to see the latest event for that user before their review date time. So for user 2, that would be this row, this event. And for user 3, it would be this event. With the ASOF join, this becomes super simple. That's the purpose of the ASOF join. It's keep the latest row in your right table before a date time that you specify. In this case, before the last review date time. The way that we're going to update this SQL query to be an ASOF join is by writing ASOF before left join. This means that in DuckDB, ASOF is a join modifier, just like the natural keyword that we saw in the last video. It modifies the behavior of a typical join. So let me give this a run to see what we get. We do indeed just get the latest events per user. Now, to really prove that this is a join modifier, if I update left to inner, what do you think is going to happen? We're going to drop users 1 and 4, because with an inner join, we drop rows that haven't found a match according to the join condition. So ASOF really is a join modifier, and it's a great way to keep just the latest row relative to a certain date time. I personally really like how DuckDB has implemented ASOF, using it as a join modifier for your normal fundamental joins. But just to be really clear that this is DuckDB, let me just add a quick note up the top. This is DuckDB. I mentioned that Snowflake, the cloud warehouse, the cloud data platform, they also support an ASOF join, but the syntax is slightly different. So I'm not going to be able to run it because I don't have access to Snowflake on this computer, but I'll show you how we could convert this into the equivalent Snowflake syntax. So for the most part, it is identical. It's still a join, but instead of being a join modifier, Snowflake has implemented ASOF as an actual join type itself, which means that you write ASOF join rather than ASOF left or ASOF inner. Snowflake have also added a new join condition specifically for the ASOF joins, and that is match condition. And in match condition, you need to specify some kind of quality condition, or not quality, less than, greater than condition, specifically with the column on the left being from the left table, the from table, and the column on the right being from the right table, the joined table. I just make this explicit because this isn't common in SQL. Usually you can write columns in whichever order you want, but in Snowflake, you specifically have to do the left column, the from column on the left, and the right column, the column in the join on the right. So we've moved the condition up to the match condition. So I'm going to delete the and, but we still have the on like normal. The last thing that I'll mention is that Snowflake's ASOF join is always a left join. So really, for these to be equivalent, I'd have to put this one back to left join for DuckDB. If you want to implement the inner join, you will then have to go and add in the where clause yourself to filter out any rows that weren't matched in this join. But you can see that these are fairly similar. They've both got in this particular case, an equality condition on the user ID, because we still need to match up the users with their events via the user ID. And then we have a condition, a specifically less than or greater than condition, where we're comparing a date time from the right table to a date time on the left table. And we're keeping the date time on the right table that is closest to the date time on the left table. So in this case, it's the closest event date time to the last review date time, where the event date time is less than or equal to the review date time. Let's loop back around to the DuckDB example, the DuckDB syntax. I just want to make a couple of comments about what's currently supported in DuckDB. So let's give this query a run just to remind ourselves what the output looks like. Here we go. You'll see that for user 2, their latest event relative to their review date time is a logout event, and for user 3, it's a login event. We could, if we wanted to, filter for just the login events. What was the latest login event? And that's just as simple as adding an extra condition in the join. So I'm just going to whack it up here. I'm going to say I want the event type to be equal to login. So the way that we're associating these records is still via the user ID. I only want to keep the events, that's a login event, and I want to keep the event that is less than or equal to the last review date time, but the closest one to it. Let's give this a run to see how it changes the output. Here we go. We now have the latest logins relative to that date time for each of these users. On the version of DuckDB that I'm using, it's 0.9.2. This is only supported for the left join. If I try and do an inner join with this extra condition in here, we're going to get an error. It's not okay with it. So just be warned that currently on 0.9.2, this is only supported for the left join. Let's go back to not having the extra login filter. We'll rerun this one. We can also use the using join condition for ASOF joins. When we use using, and we're doing it with an ASOF join, the last column that we have is going to be the one where it does some date comparison. Now, if it's a using, we know that the column names need to be the same. So just give me a minute to adjust some of this data so that we're going to have the column names for the date time columns be the same so that we can whack them into a using. I wouldn't do this in practice with this specific data set, but we're going to do it just so that we can illustrate how the using join condition works for ASOF joins. So bear with me 2 seconds. Here we go. So the query on the bottom is just an adjusted version of the query that we just saw, which I've left on the top. All I've done is I've just read the events table into this events adjusted CTE. I've renamed event date time to last review date time to match the name of the column that we have on the users table. And then I've updated the join condition to be a using. So in this specific case, because we're using the ASOF join modifier, DuckDB knows that we want a quality on the user ID, just like we have here, but that we specifically want the user's last review date time to be greater than or equal to the events adjusted last review date time, which remember is just the event date time. I've just renamed it for the purpose of this example. So this will expand out into the same as this. Let's just prove it by running each of these. I'm going to run this one. These are the events that we get. And let me run this one. These are the same events that we get. Now I've only kept the last review date from the users. Let's do the one from events as well, just to prove that it is the same thing. Here we go. Outputs are absolutely identical. Just in case the previous example wasn't an illustrative enough example, another place where you may want to use the ASOF join is if you're dealing with transactions and you need to convert them using some exchange rates. This would be a great place to use an ASOF join because the exchange rates will have a fixed point in time where they changed, and you always want to use the latest exchange rate relative to your transaction time. So this query in front, this is how we would get the exchange rate for a transaction from a currency into US dollars. By doing the ASOF left join, we keep all of our transactions and we're going to keep the latest exchange rate relative to the transaction date. No funky row numbers or correlated subqueries or anything like that to just keep the latest one relative to our transactions. We just whack in an ASOF and we can keep the latest exchange rate relative to our transactions. I was using ASOF joins recently at work. So for context, I deal with supply chain data. So deliveries going into depots and stores and stuff. And we were using the ASOF join to match deliveries with the stock balances that we had in different depots. So we could see when a delivery was made into the depot, what the corresponding stock balance was in that depot at that particular point in time. So if we knew that the stock when the delivery happened was 10 units and we delivered 5 more units, we could very easily then say that we now had 15 units at that particular point in time. So ASOF joins, such a fantastic addition to the SQL join toolkit. You may be wondering how you can emulate this ASOF join in a database that doesn't currently support the ASOF keyword. So we're going to go through 2 examples where you can get the same output without using this ASOF keyword. There's loads of ways to get the same output. There's loads of different approaches that you can take, and the approach that you take really depends on your data It depends on your skill set, how familiar you are with the different elements of the language. It depends on what features are available in the database that you're using. There's loads of factors. One of the main ones will be performance as well. Different approaches perform differently depending on what your data feels like. So we're going to go through just two examples, two alternatives for using the ASOF, but they're not the only alternatives. The first alternative is using a lateral join, which we haven't covered yet, and I will be covering in another video, but a lateral join is just a generalization of a correlated subquery. So let's give this a run just to prove that it works. Like I said, I'm going to do a video on lateral joins later to really go deep into them, but what we're doing here is we're doing a join onto a subquery. So for each user, we're going to go and grab some events from the events table, where those events correspond to the same user, and where those events are earlier than the last review date time for that user. And these two conditions are precisely the two join conditions that we had in our ASOF join. Now the special thing that we're doing here is we then order the resulting events, because this will be all events before the date time, before the review date time. We then order the events by the event time in descending order, and we keep the most recent one. We keep the top one. Since this is a correlated subquery, because it's lateral, this runs per user. So per user, we're going to get one event back. And because of the way the left join, because we're doing a left join with lateral, and we always need a join condition for the left joins, this is why you'll see an on true, sometimes you might see on 1 equals 1. But this is the way that a lot of databases or a lot of people will implement the ASOF join in a database that doesn't support the ASOF join keyword. The only thing about this one is you need a database that supports lateral, which not all databases do. So if you are using a database that does support lateral but doesn't support ASOF, it's quite common that you'll see, well, it's not common, but if you want to implement an ASOF join, or colleagues of yours have implemented ASOF joins, it's not uncommon, or it's not unlikely, that they would have done one of these lateral joins. The next approach is using a row number. So let's say you're using a database that doesn't have the lateral join type, the lateral keyword or concept, because in SQL Server it's cross-apply rather than lateral. And let's also assume that it's a database that doesn't have qualify, which is the window function equivalent of having. It allows you to filter by the results of window functions. So we're going to keep things really simple, really kind of bare bones database features. In this particular case, we're going to create a CTE, which pretty much all SQL databases support, if not all of them. We're going to have an initial join, where we join the users to the events. We're going to do it on the user ID like normal, and we're going to keep only the events that happened before the last review date time. So this is going to be lots of events per user, most likely. But then we're going to whack in a row number. We're going to do it per user, and we're going to put the events in descending order according to the event date time. It's going to give us a list of numbers going 1, 2, 3, and so on for all of the events. But because we're ordering them in descending order, we can then filter the event row number to be just the first one, and that will give us the most recent event relative to the last review date time. If you've not used row numbers for filtering like this before, it's definitely something I recommend you wrap your head around. It has come up so many times in my career. People will commonly replace this, like subquery, where equals 1, and row number with a qualify equals 1, where the database supports qualify. So I'm just saying that this is a very common pattern to use for selecting the latest record of something. Like I said, these are just two approaches to try and implement ASOF without using the ASOF keyword. The approach that you take may be totally different to either of these, and it totally depends on your data, and it totally depends on your performance requirements, your skill set, whatever. However, I hope these examples have helped you appreciate just how much the ASOF join simplifies our joins, because this is not an uncommon way that we want to combine data. It's very common for us to want to combine data based on timestamps that are misaligned. So the ASOF join really is such a great addition to SQL. I strongly encourage you to at least try and find a place where you can use it yourself. To wrap up, we've seen that the ASOF join type is a great way to join data that has misaligned date axes across two different tables, just to keep the latest record relative to another record between two different tables. At the moment, the ASOF implementations, at least for DuckDB and Snowflake, are slightly different. DuckDB treats it like a join modifier, whereas Snowflake has implemented it as a new join type with this match condition clause that you need to specify as part of your join conditions. But the way that they function is very similar. The ASOF join in Snowflake is just like an ASOF left join in DuckDB. We saw that in DuckDB, we can instead do ASOF inner join, since the ASOF is just a join modifier. And we also saw that we could use the using keyword in DuckDB as well if the column names were the same. It's just that the last column in the list of the using columns would need to be the date time column that we want to compare. Finally, if you're using a database that doesn't have ASOF, you can replicate the ASOF behavior by using a lateral join, a row number, or any other approach that works for you. Are you using a database that has ASOF as well? Let me know in the comments below. I hope you found this helpful though, and we'll catch you in the next one.